Let me tell you about a volcano that doesn't look like a volcano. No dramatic cone, no smoking peak rising above the clouds. Instead, picture this. 500,000 people waking up in their apartments, walking their children to school, opening cafes for the morning rush. They're doing all of this on top of one of Europe's most dangerous geological features, and most of them have no idea what lies beneath their feet. This is Campi Flegrei, just west of Naples, Italy. And what makes it so profoundly unsettling is not what you see, it's what you don't see. It's a volcano in disguise. A caldera, a vast hidden bowl carved into the Earth's crust by catastrophic collapse 15,000 years ago. And right now, that sleeping giant is waking up. I've spent decades studying how natural systems behave when they're pushed to their limits. I've looked at earthquake swarms, analyzed volcanic gas emissions, and tried to understand the mathematics of collapse. What's happening beneath Naples is a masterclass in how a geological system can hide its most dangerous secrets in plain sight, written across ordinary city blocks and everyday lives. Let me walk you through what the science is telling us. And then I want to talk about why officials are caught between two impossible choices. The hidden architecture beneath the city. To understand Campi Flegrei, you have to first understand what a caldera actually is. Most people think of volcanoes as mountains, cones, things that rise up. But some of the most dangerous volcanic systems don't rise at all. They sink. They collapse inward, creating vast depressions in the Earth's surface, sometimes spanning dozens of kilometers. Campi Flegrei stretches across 13 kilometers of western Naples. From the streets, it looks like any other densely packed European city. But from above, if you look at satellite imagery, you can see the subtle truth. There's a curved arc, a faint outline, the rim of an ancient crater wall now hidden beneath apartments, shopping centers, and traffic-clogged streets. Here's what happened. About 15,000 years ago, a series of massive eruptions emptied the magma chamber beneath this region. The ground lost its support. The roof caved in. The surface dropped, creating a wide, shallow bowl, ringed by low hills and ridges that now blend into the urban sprawl. For millennia, this scar filled with settlements, with history, with the accumulated weight of human civilization. Today, nearly 6 million people live in the greater Naples metropolitan area. The caldera's floor appears flat and ordinary. Yet every block, every building, every piazza, every school is built on layers of volcanic ash and ancient lava flows. The volcano is invisible, but it's not gone. Beneath the city streets, just a few kilometers down, the ground remains restless. There's heat, there's pressure, there's a vast reservoir of gas, and according to some research, potentially magma rising closer to the surface than authorities have publicly admitted. The breathing ground, if you want to understand what's really happening at Campi Flegrei, you have to go to Paisiarelli. This is where the volcano stops hiding. This is where you can actually see it breathing. Paisiarelli is a field of fumaroles vents where volcanic gas pushes directly to the surface. Thousands of tons of volcanic gas every single day. The numbers are staggering, between 4,000 and 5,000 tons of carbon dioxide daily. That puts Campi Flegrei among the highest daily gas outputs measured at any active volcano on the planet. And it's not declining. Every new measurement tells the same story. The system beneath is charged, it's restless, and it's forcing its way to the surface. Stand near the main vent and you can see temperatures exceeding 115 degrees Celsius. Water doesn't boil there. It flashes instantly to vapor. The air shimmers with heat. Gas monitors tick upward as plumes drift across, stinging eyes, catching in throats. The ground itself is etched with mineral stains, yellow, white, green. Where vapor cools and condenses, it leaves behind a crust of elemental sulfur and other compounds. These are not just surface decorations. This is the volcano's chemistry made visible. But here's what troubles me most. The gas doesn't stay at Paisiarelli. It moves. It travels laterally through loose soils, through cracks, even under building foundations. It finds its way into homes, into the spaces where people sleep. Measurements inside nearby buildings show that carbon dioxide concentrations can rise far above outdoor background levels, especially overnight when the wind dies down and gas accumulates indoors. It's not just carbon dioxide. Hydrogen sulfide, that sharp, rotten egg odor, and sulfur dioxide, which burns the lungs, are also present. In some rooms, gas reaches levels that trigger health warnings, headaches, dizziness. Residents who spend time indoors report symptoms they struggle to explain to their doctors. The mineral-laden vapors are transforming the built environment. As hot gases rise through foundations and cool inside homes, they shed their mineral load. Sulfur, chlorides, other compounds. They condense and harden into thick yellow and white crusts that coat tiles, walls, and furniture. In the worst-hit homes along Via Antinana, residents describe scraping mineral deposits off their floors with shovels only to find them back within weeks. It's relentless, it's invasive. And it's happening inside ordinary apartments where ordinary families are trying to live ordinary lives. The infrastructure is suffering too. Sidewalks buckle, water mains corrode. Gas lines become brittle where volcanic fluids pull through the subsurface. Maintenance crews patch the same stretches of road over and over, but the vents always return. Each new crack in the pavement is a reminder that the volcano doesn't respect city boundaries or engineering fixes. The boundary between the caldera and the built environment is vanishing. The ground is rising. Now, let me tell you about something that's even more troubling than the gas. The Earth itself is moving upward. Pozzuoli has risen 1.4 meters since 2005. That's in just 2 decades. A slow-motion heave that warps roads, splits foundations, and strains both ancient and modern infrastructure alike. The Roman amphitheater in Pozzuoli, a monument that has survived 2,000 years of earthquakes and eruptions, is now being damaged not by massive ruptures, but by this quiet, relentless uplift. Fresh cracks are opening in ancient masonry. Mineral-laden steam is seeping into vaults and corridors, leaving stains and deposits that threaten structural integrity. And then there are the earthquakes. On June 30th, 2025, Campi Flegrei was rocked by a magnitude 4.6 earthquake, the strongest ever recorded in this region. It wasn't an isolated event. In the past year alone, 5 earthquakes above magnitude 4 have shaken the red zone, sending cracks through apartment blocks and forcing families from their homes. But those are just the ones people felt. Traditional monitoring stations logged around 12,000 earthquakes in the last 3 years. 12,000. But when researchers applied artificial intelligence to comb through the raw seismic data, the true number was revealed, closer to 54,000. Most were too small to feel, but together they tell a story that's impossible to ignore. Relentless fracturing, stress accumulating beneath the surface. Microquakes swarm in patterns that trace out hidden faults and fractures pathways for gas, heat, and potentially magma to travel toward the surface. This isn't the first time the caldera has sent these kinds of warnings. In 1538, a surge in seismicity and ground uplift culminated in something extraordinary. A new volcanic cone, Monte Nevo, suddenly rose from farmland in a matter of days, The eruption buried fields, forced evacuations, and left a crater that still scars the landscape today. The parallels are impossible to ignore. Uplift, swarms of quakes, a restless volcano pushing at the limits of its underground prison. Each new tremor, each centimeter of ground rise adds to the strain. The caldera is not a passive landscape. It's an active system storing energy and searching for release. The mystery beneath the city. Now here's where the science becomes deeply unsettling, because not everyone agrees on what's happening at depth. Two recent scientific studies have drawn very different conclusions about the volcano's internal state, and the gap between them is not merely academic. This is about how we interpret the signals, the seismic data, the gas emissions, and what they tell us about the location and state of the magma. One group, working with the Istituto Nazionale di Geofisica and collaborating with University College London, built their analysis around earthquake relocation data and surface gas readings. Their conclusion: magma may be rising to within 4 kilometers of the surface. According to their interpretation, Campi Flegrei is entering an extremely dangerous phase. They called for authorities to classify the region as being on the verge of a critical transition. They argue that the patterns of carbon dioxide spikes and shallow seismicity point to a growing risk of eruption. The second group, led by researchers from Stanford and collaborating European institutes, pushed back. Using advanced seismic tomography and magnetotelluric imaging, they presented a different picture. Their models show a gas-rich hydrothermal reservoir between 2 and 4 kilometers deep, but no clear sign of a large melt body shallower than 4 kilometers. According to their interpretation, most of the signals, the ground uplift, the gas emissions, even the recent earthquake swarms, can be explained by pressurized gases moving through fractured rock, not by a surge of magma approaching the surface. They caution that the system is volatile, but they insist that the risk of an imminent large eruption is lower than some headlines suggest. So here's the problem. Both groups are using sophisticated, state-of-the-art tools: seismic tomography, magnetotelluric imaging, complex models built on years of data, and they're reaching different conclusions. Why? Because these models are extraordinarily sensitive to assumptions. Small changes in how earthquake locations are picked, small shifts in how rock properties are calibrated, can move the apparent depth of key features by hundreds of meters. The choice of which seismic method to use, the way gas ratios are interpreted, even the selection of which earthquakes to include in the analysis, all of these can swing the final result. Without full access to raw data sets, it's nearly impossible for outside experts to independently verify these models or test the assumptions. What this means for 500,000 residents is deeply unsettling. Uncertainty does not equal safety. The science is not settled, and the stakes are measured in human lives. The economics of risk, behind closed doors, city officials and business leaders face a dilemma, a real dilemma. Prioritize public safety or protect the local economy. The hospitality industry is significant here. Hotels, restaurants, tourism infrastructure. Real estate is valuable. Property developers have been quietly pressing regional authorities to avoid even mentioning evacuation drills. They worry about lost bookings, plummeting property values. Leaked records from 2024 show hospitality groups sponsoring reassurance campaigns, urging officials to frame the situation as under control and to delay large-scale evacuation drills. Minutes from an emergency council meeting in September 2023 reveal something stark. After a magnitude 4.2 earthquake, plans for a test evacuation were shelved, not for technical reasons, but following a meeting with business representatives. Emergency planners draft routes, they revise them, they prepare for scenarios, but when it comes time for actual implementation, the discussion shifts. A false alarm, local mayors warn, could devastate the region's fragile tourism economy, trigger a real estate collapse. Meanwhile, requests for continuous gas emission data from Picciarelli remain only partially answered. Officials cite technical delays, but the gaps breed suspicion among residents and independent scientists. The result is a standoff, a population perched atop an active caldera, caught between the logic of safety and the inertia of economics. Life above the volcano. In the neighborhoods closest to Picciarelli, daily life is shaped by symptoms that few outsiders ever notice. Residents wake up to burning eyes, persistent coughs, a metallic taste of sulfur in the back of their throats. Headaches and skin rashes are common, especially after nights when wind dies and gas accumulates indoors. Local doctors have tracked a steady rise in health complaints tied to volcanic emissions. The elderly and children are most at risk. Some families keep windows taped shut. They avoid certain rooms. They move beds away from walls where mineral crusts are thickest and the air feels hottest. This is not abstract fear. This is daily adaptation to living above a restless volcano. But resilience runs deep here too. Facing official delays and incomplete data, residents have turned to their own tools. Thousands now use smartphone apps and low-cost sensors to track tremors and gas levels in real time. They share alerts across neighborhoods. Crowdsourced vigilance fills the gap left by government monitoring, giving people a measure of agency even as the ground shifts beneath their feet. For many, survival depends not just on official warnings. It depends on the collective watchfulness of neighbors and friends, the uncertain future. Let me be clear about what we know and what we don't know, because this matters. We know that Campi Flegrei is one of the most densely populated volcanic regions on the planet. Over 500,000 people live in the official red zone, directly above a caldera that last erupted in 1538. We know recent weeks have brought daily earthquake swarms up to magnitude 4.6. We know there's been more than 1.4 meters of ground uplift since the 1,950 seconds. We know that volcanic gases and minerals are physically invading homes, roads, and public buildings, not as invisible threats, but as tangible, visible damage. We also know that scientific debate continues. No official consensus exists on the depth of magma or the immediate likelihood of eruption. Advanced monitoring technology hasn't resolved the fundamental uncertainty about what's happening beneath the surface. What we don't know, what troubles me most, is what will trigger the transition from slow motion crisis to acute emergency. Will it be a magnitude 5 earthquake? Will it be a sudden acceleration in gas emissions? Will it be something we haven't anticipated? And when that moment comes, will 500,000 people be able to evacuate safely from a region where evacuation planning has been repeatedly delayed? These are not theoretical questions. They're questions about how humans prepare for or fail to prepare for natural disasters that we can see coming but can't quite predict. The facts demand constant vigilance and transparent reporting from all authorities involved. The volcano is no longer hiding. The question is whether the response will match the scale of the risk.